in terms of some percentage forms, right? Because probability is nothing but using the historical calculations or using some historical information I am making some kind of interpretation saying what is the chance of something to occur. Probability, or when we use the word probably also, we say the same. It's a chance of something occurring. So I have observed the historical data. In the historical data, probably there were 20 times when the returns were positive out of 50 days. So 40% was the number of days, 20 out of 50. 40% was the number of days where the returns are positive. Now, can I make some kind of an interpretation saying even in the future, the chance of me becoming profitable is around 40%. So that is where we are using the concepts of probability. Using historical information, deriving some kind of numbers for the future. So that is where we are calling, we are talking about probability, right? So most of the times we use it in the sense, okay, there is a 20% chance that the price will go up, 80% chance that the price will go down. For those kind of typical calculations is what we use the probability for. And where are those coming from? Probably from our historical observations. How do I say? There are different ways I can say. One, I can say based on the past. Yeah, in the past I have observed that 20% of the times it has gone up and 80% of the times it has gone down. So I may say that in the future also there is a 20% chance of up or down. Or someone else may say, no, past was completely different from the future. I feel there is a 50-50 chance for the future. So probability is nothing but a chance of something happening. And there are different ways in which you can define the probability, right? In simplistic sense, we are talking about the chance, which means we are moving away from the historical. In the earlier chapter, everything was on the historical data, calculations on the historical data. But now we are making a shift. Based on that information, can I use it for my future? The probability is talking about the chance of occurring in future, the chance of occurring or not occurring of some kind of an event. So that is where we talk about something called a random variable to start with, because anything where the outcome is uncertain, we call it as random, right? Tomorrow's stock price, up, down, it's uncertain. That I will call it as a random variable. And that random variable can have any number of outcomes. It can be, at least in this example, it is primarily like up or down or no change. But if I say my percentage change in price compared to today, tomorrow's percentage change in price compared to today, then it can take any value, 1%, 1.1%, 1.45%, minus 1.23%, whatever it is. These are the various values which a random variable can take. Random variable is something whose output I don't know. It comes through chance. Any outcome can come on a random basis or on a some specific, there is a randomness associated with the outcome. So you can think of anything to talk about the future, we can call it as a random variable, because we unless we are fully sure that this is what will occur, otherwise we are calling it as a random variable. The values which it can take are all called as the outcomes. Multiple, any value that it can take are called your outcomes. And sometimes what we might be interested in is some specific outcome or a series of outcomes which I want to track out of them. Like positive, negative, up, down kind of probability, up, down kind of outcome. I want to track only the up. What is the chance that something goes up? I want to track only the up part. So Those are what I consider as my events. A group of probability, a group of outcomes which I would like to track. Out of the total set of outcomes, something which I would like to track for future purpose, for decision purpose, I am calling them as the events. Now, within that event, so as I said, up, down, only if I want, they are the outcomes. If I want to track only the up, then up, the probability of going up is what is of my interest to me, but not the down. The chance of going up is more interest to me, not that of the down. So, in that, before we do the computation, we talk about couple of types of events. Mutually exclusive. When I said two events are mutually exclusive, if one occurs, the other cannot occur. If an up occurs on a particular day, down cannot occur, or vice versa. So, those kind of events we are calling them as mutually exclusive. And when I say exhaustive, at least one of them will definitely have to occur. Right? If I combine all those events, it should talk about the whole space. All outcomes should be included. If I say up and down, these two are mutually exclusive. And if I say these two are exhaustive, I don't say these two are exhaustive. Because apart from up and down, no change also could be there. Right? If I combine up and down, all days of up, all days of down, it does not give me the total number of days. Probably there could be some days where there is no change. But if I combine all these three events, then I may say they are mutually exclusive. All three are mutually exclusive. If one occurs, the other don't occur. And all three are exhaustive also. This is something which we very much use in probability world. We are more interested in those kind of events which are mutually exclusive as well as collectively exhaustive. Collectively exhaustive, not in isolation. If I combine all the events, at least every outcome should be a part of at least one of that event. If I say, let's say throwing a dice, getting an even number is one event, getting an odd number is another event. Mutually exclusive, but even when I combine them, they are exhaustive also. I cannot get any other number apart from even and odd. But if I say event A is getting an even number, but event B is getting a number greater than 4, they are not mutually exclusive, because there, if one occurs, if an even number occurs, there is a good chance that it might be greater than 4 also. And coming to mutually exhaustive, if I combine these two events, it's not the whole space. 1 is not covered in any of them. 3 is not covered in any of them. So all possible outcomes are not covered in the combination of the two events. Then we don't call them as exhaustive, otherwise we are calling as exhaustive. The reason why we talk about is, if I have to make some prediction, if I have to make some conclusion about a particular stock price moving up or moving down, I need to know first of all how many outcomes are possible. Out of them, I want to see what is the one which I would like to track. Without knowing how many outcomes are possible, which is that exhaustive set of outcomes, without knowing how many outcomes are possible, I cannot track how many I want to track. Right? So that's the reason whenever we define the probability also, we say out of the total number of outcomes, how many are the ones which I am tracking? How many of them are favorable to me? So when I am looking at number of up days and down days, what is the probability that the price will go up tomorrow? If I am just observing the data and making a conclusion, the simple thing I am making is, okay, I have observed last 50 days of data. Out of that 20 days there is an up, 5 days there is no movement, 25 days there is a down. So if I want to use that data as an information for the future, I will say the probability of going up is nothing but 20 out of 50, saying 40% chance. That's so unless I know all the up, all the no change, all the down, I cannot make conclusion about the chance of something occurring in future. So we need a mutually exclusive and exhaustive set of events to define our probabilities in a very effective manner. So something, because we always talk about number of